Okay, so we want to expand. Your instructions are to expand the logarithm. We can use our rules, power, quotient, and product rules, to stretch it out to a bunch of separate logs. So this is log 12 x to the fifth y to the negative 2. I'm going to go ahead and group this. I like grouping my argument in parentheses. The book doesn't always do that, but I feel like it keeps everything organized a little better. So all of this is in the argument. So I have 12 times x to the fifth times y to the negative 2. I can use the product rule to write each one of those as its own log. And these will all be the common log because it's base 10. So I can write this as log 12 plus log x to the fifth plus log y to the negative 2. So now I have 3 separate logs, all the same base. And log 12 is done. I can't do anything more to expand the first one. Log of 12 plus the next one, I have an exponent, so I can use the power rule and move the 5 in front of the log. So that's 5 log x. Then I have plus log y to the negative 2. So I'm going to take the exponent negative 2 and move that in front of its log. So then it's plus minus 2. So I'm just going to write that as negative 2. So minus 2 log y. And so now that is expanded as far as it can go. The other situation you're going to be given is the next example, example D, where it tells you to condense. That just means you go in the opposite direction. So if you have 6 times the natural log of x minus 4 plus 3 times the natural log of x, you want to start with the power rule first when you're condensing. Look to see, is there anything being multiplied by the log? So we have 6 times the log, so the 6 is going to move and become the exponent of the parentheses, plus 3 times the natural log of x. So 3 is going to move and become the exponent for the x. All right, so we have the natural log, ln, parentheses, x minus 4 raised to the 6th power plus the natural log of x to the 3rd power. So we did the product rule in reverse. And now we have a log, the natural log, so log base e, plus another log, and it has the same base. It's log base e. That is very important. If they're not the same base, you can't use the product rule. But they are the same base, so I can write it as a single log, ln of x minus 4 to the 6th times x to the 3rd. There's a lot of slight variations on how you could write this as your answer. Like that is fine. Or you could do another set of parentheses around the whole thing to indicate that the whole thing is the argument. Or the most proper way would be to move it as the x to the 3rd first, and then the x minus 4 binomial afterwards. So x to the 3rd, parentheses, x minus 4 to the 6th. I would probably still put an extra set of parentheses around it, just because I like the extra parentheses. So I know for sure the entire thing is the argument of the log. So that is completely condensed. I can't condense it anymore. And then the last thing for today is the change of base formula, which, to be honest, we're not really going to use it very much because you would need a lot more complicated problems to actually need the change of base formula than what we're going to do. Like if you were working a problem that had a whole bunch of logs of different bases and you needed to get them together or get parts of them together, it would be helpful to be able to use your rules to combine them. So if you have a log of any base, log base b of x, you could turn them into the common log or the natural log. To turn them into common log, log base 10, you would do log of the argument over log of the base. So log of x over log of b. Or you could also do the natural log. You could take the natural log of x over the natural log of b. Either one. The first example says if you have log base 3 of 5, evaluate it. This one does seem a little silly. I don't really know why the book has us doing this one, because I'll show you in a minute. All right, so we're going to use the change of base. So we want this to be log base 10. So to do that, we have to do a log over log. So log of the argument, which is log of 5, over log of the base. The base is 3, so log 3. And then you'd still have to put it in the calculator. So log 5 divided by log 3, which equals 1.465, which I suppose if your calculator couldn't do the change of base, that it would be handy to do that, but our calculators do. And if I gave you just the 4-function calculator, it wouldn't do a log at all. So this type of example seems a little bit silly, because we could just put it in this way with a log base 3 by using the math key and then up, up, enter, and you can put whatever base you want to into the calculator. So then the second example, this one is actually a little bit useful. If we want to write this as a common log, then we would do the log of the argument, log of 2 to the 3rd power, over log of the base, log of -1. And what's the log of -1? This is like the first one from yesterday's homework. You can't. Yeah, it's no solution. The argument must be positive. If your argument is not positive, if you have a negative argument, then it's no solution. And it doesn't matter that it's in the denominator. It could have been in the numerator. If it was negative, if it's a log of a negative, is no solution. So that tells you that if your log base is negative, you're going to end up with no solution also. So not only is a negative argument lead you to no solution, a negative base will also, because you would end up with a negative argument if you try to change it. All right, so here's, again, it looks like a lot of problems. It's because I wrote out every single one of them. I did make a note on number 8, because you're supposed to be doing that section with no calculator, and it asks you for the natural log of 1.6. So if you're doing that with no calculator, I would, on a test or a quiz, I would not give you 1.6. I would give you a fraction like 0.75 or 0.5 and tell you to do it that way, because you know those fractions. I wouldn't make you turn 1.6 into a fraction without a calculator. So I went ahead and just gave you the fraction. It's 8/5. So 1.6 is equivalent to 8/5.